Just as we use those inverse operations of addition and subtraction to solve inequalities, we can also use the inverse operations of multiplication and division to solve inequalities. So right now when I see the inequality of 5x is greater than 12, that means, well, I need to find the solutions of numbers I can plug in for x so that when I multiply them by 5, I have a product that's greater than 12. So when I think about that, there's going to be multiple answers. There's many different numbers that I can multiply by 5 and get an answer that's bigger than 12. So that's when I graph my solutions, I'm going to use those arrows to show that there's multiple solutions. So right now when they're smushed together, that's showing multiplication. The opposite of multiplying by 5 is dividing by 5. My 5's will cancel out and I'll be left with the solution of x is greater than 12 fifths. Remember, 12 and 5 do not have any common factors, so your answer is just that improper fraction of 12 fifths. When I draw my number line, I can place 12 fifths on my number line, and anything smaller than that would be 11 fifths, or greater than that would be 13 fifths. I'm not including 12 fifths as a solution because I have to be bigger than 12 fifths to be a solution because it says x is greater than 12 fifths. So I'm going to use an open circle to represent that I'm not including 12 fifths as a solution. And everything bigger than that would be represented by everything to the right of that on the number line. In this next example, x is being divided by 5. Remember, fraction bar means divided by. So the opposite of dividing by 5 is multiplying by 5 on both sides. Then I'm left with a solution of x is less than negative 15. So graphing my solutions, once again, I'm not including negative 15 as a solution because I'm everything that's less than that. So I use an open circle, and anything less than that would be to the left on my number line. In this next example, I'm multiplying by a negative 7. So the opposite of multiplying by negative 7 is dividing by negative 7 on both sides. So that leaves me with x is less than, well, 14 divided by negative 7 is negative 2. Now, if I go back through and check this answer, so if I find a number that is less than negative 2, okay, that would be something like negative 4. So if I try plugging in negative 4 in here for x, that would give me negative 7 times negative 4 and seeing, is that less than 14? Well, remember about our rules of multiplying with negative numbers. If I multiply a negative times a negative, that's going to result in a positive. Positive 28 is not less than 14. So to deal with this, when we ever multiply or divide by a negative to get our x by itself, we are going to need to flip our inequality symbol to help counteract that property. So right here, I was dividing both sides by a negative number. It's what I did to both sides. So I need to change that less than sign to a greater than sign. Then my solutions on a number line, I'm not including negative 2 as a solution. So I need to include an open circle at that point. And I'm everything that's greater than that. So my arrows to the right. So if I think about something that's greater than negative 2, well, that would be a possible answer of negative 1. So if I plug negative 1 in for x, I have negative 7 times negative 1, seeing is that less than 14? Remember, you can always plug back in and check your answer. Negative 7 times negative 1 is a positive 7, and yes, that is less than 14, so it works. So there's your rule. When you multiply or divide by a negative number when solving for inequalities, you must switch the inequality. So if you ever have to multiply or divide by a negative number on both sides, be sure to flip that inequality sign. So in this example, we're multiplying by a negative 3/4. Remember, to get rid of a fraction attached to a variable, you multiply by both sides by the reciprocal. So the reciprocal of negative 3/4 is 4 over negative 3. I'm also going to multiply this side by 4 over negative 3. Well, I'm multiplying both sides by a negative number, so I need to make sure I flip that inequality. These all cancel out because I have the same thing on the top of my fraction as I do on the bottom, and also the same thing on the top as I do on the bottom. So I'm left with W, I have to flip my inequality sign, is less than or equal to 3 as a fraction is 3 over 1. Top times top would be 12, bottom times bottom would be negative 3. I can simplify that fraction because 12 divided by negative 3 is a negative 4, so W is less than or equal to negative 4. My solutions on that graph, I would include a closed circle at negative 4 because I can include the negative 4 as a solution because I have this or equal to sign on my inequality. So I'm going to include a closed circle there. And I'm everything that's less than that, so I'm going to go to the left on my number line. This next example has 2 steps to solve it. So right now I am dividing by 3. So the opposite of dividing by 3 is multiplying by 3 on both sides. Notice, I multiplied both sides by a positive, so I do not need to flip the inequality sign. This results in something that's left of negative n is less than negative 3. Remember, negative n is really saying negative 1n is less than negative 3. So right now I'm multiplying by a negative 1. The opposite of multiplying by a negative 1 is dividing by a negative 1 on both sides. Notice here, though, I am dividing both sides by a negative, so I need to flip my sign. So this results in n is greater than negative divided by a negative turns positive, so that would be a positive 3. So my solution's on my number line. I'm everything that's greater than 3, so I should include an open circle and an arrow to the right. All right, so now for some application problems. You decide to walk dogs in the neighborhood after school. You earn $4.50 per dog. So for every dog you walk, you earn an additional $4.50. It says, how many dogs do you need to walk to earn at least $75? Remember, at least means that's the smallest amount. So I want to be greater than or equal to $75. Well, if I'm earning $4.50 per dog, that means I take $4.50 times each dog I walk. So I'm going to show that per amount by doing that multiplication. Then the opposite of multiplying by $4.50 is dividing both sides by 4.5. This will result in D being greater than or equal to 16.6. Now, if I would plug 16 back into my original inequality, it would not result in an amount that's greater than or equal to 75 because I have to be greater than or equal to 16.6. Now, I can't walk 16.6 dogs. So in order to earn at least $75, I would need to walk at least 17 dogs.